Okay, so what I'm going to talk to you about today is we've been working on this Optimised Canola Profitability project for the last 3 seasons. And I want to talk to you about some of the results that we've found from that over those 3 seasons, and then how you can use that data to make some decisions going into this current growing season. So the project that we're working on is quite a large project. It's led by John Kierkegaard out of CSIRO in Canberra, and he's assisted by Julianne Lilly, also based in Canberra, Jeremy Wish, who's based up in Toowoomba in southern Queensland, and Therese spends a bit of time working out at Karoonda on this project as well. So CSIRO are doing a lot of the modelling and some of the real science, lab-based science in the project. And then we've got the agronomy team in New South Wales with Rowan Brill and Don McCaffrey doing a lot of trials through there. And our group in South Australia doing trials at mainly Yalana down the Lower Eyre Peninsula, Hart in the mid-north, and Lameroo out in the Mallee. And we've also had trials at Minnipa and Riverton in the last 12 months, and we'll be using Therese's site at Karoonda as well. So it's a fairly big project. Been working on it for 3 years now, so we've got a fair bit of data, and we can start talking about how things, we're really developing an understanding of how canola develops in the South Australian environment. So just to go straight through to the take-home messages, we've been working on time of sowing by variety interactions at those 3 sites, Yalana, Hart and Lameroo, for 3 seasons now. And it's really improved our understanding of canola phenology. And it's given us an opportunity to understand what's driving or maximising yields in those environments through both early and late sowing opportunities. And it's also we're getting to the point now where we can really understand through that phenology data that we need to have that there is an optimal flowering window for each of those type of environments. And then now we're starting to really understand, and that's what I'm going to talk about today, the development of canola varieties so that we can match that optimum flowering window with the way the canola develops so that you can sow the variety in the right window. And I'm going to just, at the end of the talk, I'm just going to put a couple of slides about how important nitrogen is, and we've just come off a season where we've had some really cracker yields, and I just put some data up there just to show how important nitrogen is in driving those yields. So 2016 in review, it was a wet year. We didn't have a lot of stress in terms of the way canola grew. We didn't get a lot of winter frost when canola starts flowering. Had a really gentle finish which suited canola. There wasn't as much of an advantage in sowing canola early as we'd seen in previous years. So in our experiments, we actually irrigate or wet the trials up to get them out of the ground in mid-April. And we didn't see that advantage like we had in 2014 and 15 from sowing early. But that matches up pretty well with some data that John Kierkegaard did back in the early 2000s that pretty much showed the same thing. So while early sowing wasn't the be-all and end-all last year, we still learnt a lot about the way canola varieties develop. We did learn that there's some varieties such as Archer that have certainly got some flexibility in when you can plant them, and it's just as an example of a variety that does suit that more flexible sowing window, sowing opportunity approach. And then we also learnt that there's some varieties that you really don't want to sow early. We've also discovered that last year, for those of you who would have heard Steve Marcroft's presentation, 2016 certainly presented itself as a very high disease risk year. And I'll put up one slide just to show you that if you flower in the wrong window, the effect that disease can have on that sort of wrong type of scenario. And as I said before, having a high yielding year certainly required a high nitrogen inputs, and like I said, I'll talk about that at the end of the talk. This is a little pyramid that Rowan Brill put together last year, just as a way of thinking about some of the levers that we've got to play with in terms of maximising our canola yields, given that weeds, insects and disease are all managed effectively. The way that we like to think of it is probably one of the biggest things driving canola yield is nitrogen. Then we've got to get sowing date by phenology right. And then to a lesser extent, getting, whether a variety is a hybrid, an OP or a TT, that's a little bit of a lesser extent. Getting seeding rate and size right makes a bit of a difference, but not a lot. And then making sure that you get your other nutrition right. If you've got an extreme deficiency, that can create a real issue. But for most of South Australia's canola cropping area, getting trace elements and everything like that balanced is just a bit of icing on top of the cake. So we're going to spend most of today talking about this area here, finish on here. But just to make a quick comment on that one, because I've finished a SAGIT 3-year project last year, wrote it up. We spent a lot of time doing seeding rate, seeding depth, different soil type experiments. And in a nutshell, what we found out of that is canola is a very plastic plant. You can get away with sowing very low rates, or getting low rates of establishment down to about 15 plants, and you still get a really respectable yield out of it. But if you want to consolidate your yield and make sure that you have a consistent yield, you can't afford to go probably below about 45 plants a square metre. And if you're growing an open pollinated TT and you may be retaining seed, the seed doesn't cost you a lot. There are some opportunities to increase the seeding rate there, and where it's going to help maximise your yield more often than not. So I'm going to start now talking about the experiments that we ran last year. So this is the first one at Lameroo. So Lameroo last year was started off very dry. So these three times of sowing at Lameroo last year, from the middle of April to the middle of May, the guys from Sturt had to go up there with dripper pipe and irrigate this to get out of the ground. Hardly saw a drop of rain until the mid to late May. So all of this was brought up with irrigation. The season then kicked off. We pretty much had average rainfall through the growing season up until about the end of August, and then just about like everywhere else in the state, it started getting wetter. And one of the other things about Lameroo last year was that we typically see a lot of winter type frosts, and last year the average temperature at Lameroo was certainly warmer just due to the number of cloudy days that we had, and those winter frosts weren't quite so prevalent. So that made a few things happen a little bit differently at Lameroo last year than what we've normally seen. So typically in Lameroo we would just see you just sow early, sow any variety early, and that's the best way of maximising yield. So last year, as you'll see in a few of the other slides, sowing an early variety, really early, there's no advantage in it. Sowing like new seed diamond is the quickest. It's actually slightly quicker than Stingray. Sowing that early, there was no yield advantage at this site last year. You sow, this Arch is the latest variety we had in this suite, you sow that early and there is a yield advantage. So we're just starting to see some of the differences in having varieties with the flowering time matching the right flowering time to maximise yield. And the next example is moving from Lameroo down to Lower Eyre Peninsula. And this is exactly the same suite of 9 varieties, sown at very similar times in a slightly warmer and wetter environment. You can again see no advantage in sowing early with a variety like Diamond. Really high yield upside in sowing that variety in the middle of May, but absolutely no advantage in sowing it in the middle of April. Really quick variety. Again, you look at the flip side, the latest variety we had in this experiment, Archer, didn't perform quite so well. It didn't perform anywhere near as well as what Diamond did, but it still yielded really well, a solid yield package over those 3 sowing times. So why is this sort of thing happening? First thing we're going to look at is flowering date. This is a bit of a busy slide, but it shows you the wide spectrum of flowering dates. So this is the start of flowering, this box through here. You can see that some of the varieties that's in this first time of sowing that went really early and yielded low, like Diamond, started flowering in June. Stingray likewise. Whereas some of the varieties like Archer that yielded quite well in that first time of sowing started flowering in the first week of August. So there's a number of things that having that flowering date in the right window really helps set up in terms of yield. Just to touch on some of the things that can go wrong when you have the wrong flowering date, I'm going to put up this one. This is the only disease slide that I want to put up, and it's I'd refer to Steve's talks for more in-depth information about disease. So this is on those same plots we did a 0 to 4 score at maturity on the number of blackleg lesions we saw on pods, like these guys up here. The 0 to 4 score, so with anything that scored a 4 meant that 50% of the pods in those plots had at least one blackleg lesion. And you can see from here, if you sow stingray early in this environment, you get a perfect score. It's an absolute cracker way to get a heap of disease. So this is a variety that is flowering in this late June period. So stingray is what we call a Group C. Got a Group C major gene resistance. So Archer also happens to have that Group C resistance. So you can see when you flip that, so Archer we started flowering in the first week of August, and you can see the disease levels are considerably lower. And even Diamond in this area here, Diamond starts flowering about the same time as Stingray, but it's got a little bit more effective blackleg resistance, and so we saw less of that disease. So blacklegs, one of the upper canopy infection blacklegs, one of the things that we need to be watching out for in terms of getting that flowering date right. But just to empirically look at how this flowering date data impacts on yield, I put together the 3 years of experiments that we've run at Yalana, Hart and Lamoureux together and compared them with their flowering date and took the top 90% of yielding plots, and you can see from that the highest yielding plots at Yalana you want to be flowering within about the end of July, first week of August. You move over to Hart where they've got a bit of a frost risk, you want to be slightly later, and you move down to Lamoureux where the risk of move down to Lamoureux where the risk of heat stress is considerably higher, so it moves that flowering window slightly earlier. So this is just data that we've collected from 3 years of doing field trials, but they've been a really good selection of 3 years to be able to do work. So we had 2014, which for those of you who remember was a really warm season to start off with, had reasonable winter rainfall, and then things finished off really quickly. 2015 was a little bit more average, closer to average in terms of its winter rainfall, and certainly its temperature was average, and then it finished off equally as quickly as 14. And then we had last year, which is almost the flip side. It was a really cool finish to the season and just kept raining. And it didn't really matter which one of those years you put up there. This same pattern of having this optimal flowering window in terms of maximising yield seemed to happen in each one of those years. So there's a number of things that are happening to be able to create that optimal flowering window. You really need to, going too early reduces your biomass accumulation and exposes you to frost risk, and it also exposes you to that high levels of upper canopy blackleg infection. And flowering too late obviously exposes you to heat stress and moisture stress. So while there is this real tendency to want to plant early to maximise your water use efficiency, and there's absolutely nothing wrong in that thinking. You don't want the plant to be flowering in June or maybe even the first half of July in most of South Australia's environment. And so the data that we've collected empirically looks pretty much like the data that Julianne's starting to model. And so she's putting grain yield. This is using 60 years worth of meteorological data. So modelling yield, comparing that to historically how water stress plays out, frost stress the reducing risk of frost stress through the season, and then the increasing risk of heat stress. And you get this sweet spot through here where it's really good time to flower as a canola plant. The one thing that we can't put in this model yet is how disease interacts with that quite yet, but we'll be getting there. So now I think I've highlighted how important getting a plant to flower in the right window is. Now you guys are going to be advising or planting varieties in an early sowing window or an early sowing opportunity, and you will be wanting to hit that ideal window. And how can you best do that? And I guess this is just an example of how not to do it. So we've planted Hyola 575 at the heart site within the same calendar day of each other over those 3 seasons. And what you can see from that data, so this is the time, the length to flower, to the start of flowering. And you can see if you plant Hyola 575 in that heart environment in those 3 seasons, the difference or the variation you get from to the start of flowering, it almost extends over a month. And so if we're telling you that you need to hit an optimal flowering window that is about a couple of weeks wide, somewhere around the first week of August, and you can get anywhere around a month happening with your sowing opportunity, depending on what happens, whether you have a warm start to the season or a cold, wet one, it makes it pretty hard to hit that window. You compare that to 45 Y88, and you get a much more consistent response. So you can start to see, if we understand what's driving those varieties in the way they develop, then you can start planning, sowing the right variety to match that optimum flowering window and maximise yield. So this is a little bit about how canola develops. There's a whole heap of physiological things that drive its development, and in the paper I've talked a little bit about how thermal time, photoperiod and vernal time all interact to affect the time between emergence and flowering. I just wanted to spend a couple of minutes talking about where we've got to in classifying each of the varieties that we've got available to us at the moment. So the CSIRO teams at Gatton or Temora and at Canberra have run these single row experiments. The reason that we've got them up in Gatton because it provides this nice warm environment. Conversely, Canberra's been known to get a little bit cold. And then they've put lights out to take away the effect of different day lengths and things like that. And from that, it's been a lot of work. There's over 200,000 data points that these guys have collected throughout the season. Every one of these leaves that as they emerge gets counted and accounted for. And from that, we start to understand some of the way that canola varieties develop. And I don't want you to take on any of the detail here, but each one of these is a canola variety and their response to vernalisation. You can see here that quite a few of the varieties have a fairly flat effect, so they don't really require any vernalisation. Some of these down here, these are the true winter types, so you get this real obligate type of vern where they require so many days of cold temperature. That stimulates their thermal response and then they start flowering. And in the South Australian environment, very rarely do we get these guys to start flowering before about the first week of October. So if we've got their optimal flowering window is back in the first week of August, these guys get fairly hard through most of the South Australian wheat belt to match that. Probably got some adaptation south of Narracoorte, but not in most of South Australia's cropping belt, unless you're at Cummins last year where Pat grew some Hyola 970 and it really yielded well. We had a very kind finish. But what we have seen, so these are the extremes, these are the winters, but there are some varieties that just have a little bit of vern, and that's probably what's holding a lot of our varieties that we're playing with got available to us at the moment, just holding them back a little bit, and that's enabling us to get them to flower in the right window. The other thing that we've got a little bit of help with is thermal time. You can see most of the varieties that guys evaluated didn't have any response to photoperiod, so the length of day. There's just a couple that had a bit of a response to photoperiod. You can see Archer is one of those, and that's why it's become so effective in that being able to sow it in that early or mid-April type window and getting it to flower in the right window. So we've classified, I think the guys did about 26 of these last year, which covered a fair spectrum of the varieties we've got available to us. And obviously hasn't done everything, but we're starting to get a real handle on what the difference in genetics is and understanding what's driving that development and getting it to flower in the right window. So now we understand a little bit about we understand that there's a right flowering window, and so this is some modelling work that Julianne Lily's done. So this is the right flowering window to happen, and we understand how long it takes to get from sowing to the flowering window. So now we can start picking some sowing opportunities to match those varieties that we've got available to us to the sowing window, to that flowering window. So the South Australian example we've got here is Minipa. Minipa we're suggesting has got an optimal flowering window, probably a little bit earlier than some of those other environments, and that's probably driven by the fact that Minipa doesn't get a lot of frost. But with an early variety, to match that flowering window, you need to be looking at getting an early type variety in a Minipa environment to maximise yield sometime in April, which is what we've seen in our experiments there as well. Whereas flip side, you move to Inverleigh, which is just sort of near Geelong in Victoria. Got a much gentler season. Your flowering window is back well into August. You can look at like a mid to late variety sown almost into May and maximising your yield there. So that's where we're going with this. We're very close to having a website available, going live. We're hoping it'll go live sometime before seeding this year, where you'll be able to plug in your location, the variety that you want to sow, and it will give you your optimal flowering window and your best sowing opportunity to put that in. So that's very close to getting there. So in a nutshell, this is where we've got to. So we've worked out that yes, sowing early and sowing into middle of April, like most of you guys now would have a fairly full profile of moisture. Starting to get questions on how early you can go with canola. We're fairly comfortable about sowing into mid-April, but you really do need to match the variety with those sowing opportunities and match it to your environment. So environments where it doesn't work, so your Lanna or both of the peninsulas, just where you get that warmer type of environment. I didn't put up the response to thermal time on there, but as you would have gathered, most of our varieties didn't have a lot of effect with photoperiod. They didn't have a lot of effect with, there's a bit of effect with vernalisation. So most of our development is driven by thermal time. So planting varieties that don't have anything holding them back in environments that are warmer, like lower Eyre Peninsula or York Peninsula, can create a problem. So we've identified some of the varieties that you can sow in late April, like Archer, and we certainly identified some of the varieties you wouldn't want to sow, like Hyla 575, Diamond and Stingray. But we've also, Diamond as a late sowing opportunity, you're not losing anything by sowing it late. So I just wanted to finish with two slides on nitrogen. If Rowan Brill was doing this talk, he would have talked a lot about biomass accumulation and things like that. I've decided to avoid that today. But one of the things we wanted to do last year was we wanted to see if we could blow canola up, feed it so much nitrogen that it'd just grow and grow and grow and wouldn't produce any yield. The season that we got, we didn't end up doing that. So we put a ton of nitrogen on this trial, just trying to blow it up. But we only ended up really getting a yield response to about 250 kilos, and we peaked that out just a bit over 4.5 tonne. Rowan did similar sort of work at over near Wagga. Similar sorts of results, got sort of peaked out around that 250, 300k of kilos of nitrogen. The point that I wanted to get to here is nitrogen is a principal driver of canola. You would have heard John talk yesterday about how our nitrogen reserves are getting depleted in the soil. Canola requires about 80 kilos per tonne of grain to have access to that much nitrogen to be able to produce 1 tonne of grain. 80 kilos of nitrogen to produce 1 tonne of grain. So we grew 4.5 tonne. that requires 360 kilos per hectare of nitrogen. My estimate was we had about 70 kilos in the soil at sowing time, and some of the formulas that Jeff Baldock used to use on mineralisation and the amount of stubble and everything we had at this site, I think we had about 30 given to us from the soil, so 100 in total. We needed 360, so therefore we needed about 250 kilos to reach our 4.5 tonne, which is what we did. So yeah, to maximise, to really hit those peak canola yields, it's a hungry nitrogen crop. There's no other way about it. You need to be able to feed it that amount. And one of the questions that we've got, and we'd like some feedback, is how you guys are setting a target yield and how you go about, and then how you go about fertilising to get there. So back home to the take-home messages. I hope that I've been able to give you some understanding of why phenology or flowering time is important in canola, and how that we'll be able to create an optimal flowering window for each environment in South Australia, and then that how important nitrogen is to driving our yields. So, thank you.
Thanks, Andrew.